Hello everyone. So we are live, and today we have with one more session with Vishwas on Logic App Part 2. The Part 1 which we have already done, and today is Part 2 on Logic App. So firstly, let me introduce Vishwas. Vishwas is a passionate on Azure, and like he's very excited to share his knowledge with you all. So today, like I will go give to Vishwas to tell more about the Logic apps today. So yes, Vishwas.
Thank you so much, Vilsi. Thank you so much.
Vishwas, your
So,
voice is not coming.
can you hear me now? I think, yeah, fine. I think perfect. I think that's what probably for the
Okay,
task.
perfect.
Sure, I think it's not about, yeah, like let's just start with the session then. So, anytime when you think of logic apps or anything as a serverless application, which is like making sure that like there is an one complex puzzle of your entire infrastructure which is there in front of you, like it's an entire configuration files. There is an something like an infrastructure consoles, and there are a lot of other applications as well. So in the meantime, when you think of something like there is an application which is running hundreds of hundreds of calls on one application, and there are hundreds of things which are coming up, there is always a chance that it might break. But plumbing is never your opportunity, because all the problems of like network on the hardware optimization, software optimization, and the things like that have always been here. But what's the problem with all these things is like, and like there is always an quick intro for everything that is going on, and always there is always an one biased entity which is like, can we monitor billions of calls? Like let's say your company goes boom, and you want to you want to handle millions of call over one point, where that's like the tsunami way of entering into your entire infrastructure. So what matters to you at the end of the day is like, you just have this one little piece of puzzle that is yet to be solved, that is architecting your solution. And this is where your serverless comes into the picture. If you want too much of insights about what is serverless, this that, there is an amazing session which I did last time, and many people DM me back saying that what did you do in that session. And it covered everything about the serverless and this that, and everybody had their own definition for the serverless. But after the session, I just told them, okay, this is what your serverless is. And now, and afterwards I also had to convey some papers and results and things like that. So I just gave some papers, and you know everybody has a skewed definition for that. But I just tried making sure that it just falls on to some entity. Like, okay, there is a comparison made on a renting a car, renting an aeroplane, or renting anything. So let's just start with this intro about this logic apps, and let's just move on with it. So let me just share my window. This is my perfect. So all these are the things which we covered. So last time we covered everything about the logic apps, is connectors, canvas, which is actually the template of the logic apps. And by far, and also by far, there is always a template which is always there. So I'll be doing one thing. So in this time, I'll be only taking conditions here. Serial and parallel has been done. So serial also will be doing today. Today we'll also be doing a little bit of serial, a parallel, a conditional execution, and which is always about like and or. And or has an like very great definition. It's something like, don't worry if you have not seen my other sessions as well. It doesn't matter, because today what I'll be doing is kind of a basics itself. but you can just get to know what is the entire functionality all about, like something like and or functionalities. And or functionalities have a different definition when there is lot and lot of architecture which is built, like something like this has to be there. Like let's say, okay, there's a task one is happening, and then you have something called as task one and task two. There is always a definition for every task, right? There is one task which has to be done, and there's one task which has to be done. If it's or something like you can say task one happened, but task two didn't happen. Okay, fine. So task two happened, but task two didn't happen. And a lot of times these definitions are some sort of a vague analogies that we start building on, because that is what defines your entire architecture. Okay, how can I make it more fault tolerant? And this and or is an amazing functionality for it. And conditional executions need not have to be something like if you have seen Piyush Verma, sorry, not Piyush Mishra, it's Piyush Verma's talk on observability, the load balancers, Ash include, and also there are amazing talks from him. Like in that, you can think of something like an loop feedback systems, and it's always a control system. Like it's just like one thing gets passed, the other things also needs to be passed as an one valuable entity, like something like there is a chance that your architecture is going to break, but what if it doesn't break? Your logic app connectors canvas, what I did in the part one, will make sense only until you have only some sort of an infrastructure where the data comes in, there is churning of the data, and there is some insights which is taken out, or else there is a data point which is like valuable at one given point, but you don't care whether it's valuable 10 years later, you will just use it. So this is how your data sets are all about. And why I'm not taking the switch and the looping statements, it's because I'll say why, because next time I'll be doing arm and a lot of Terraform, actually arm and Terraform arm templates. I'll be doing a lot of arm templates, arm and Terraform, which will be part 3. But you know what, if I just give the simple definition of what is this and or nor and things like that, you guys will get bored and you will be like, part 3 mein it all went too advanced. So what I'm doing is now I'm just sticking on to myself with respect to a lot of conditions and conditional execution parallel, and also a serial. That is what I'll be kind of a revision of serial, but it's required because last time we connected lot and lot of other components, but now here we'll be talking more about the storage systems itself. I think I can just move on to this. I think this is part 1, right? What I did is, oh, sorry for that. All right, this is my red pen. I think perfect. So this is part 1 here. So this was exactly part 1. Part 1 is what happened here. Today is part 2, and this is where we stick on to our part 2, and this is where our part 2 has to be. So part 3 is something which I'll be taking on ARM and Terraforms here. So I've told it here. So of course, ARM templates are JSON, Terraform is HCL, HashiCorp language. And that language is no big deal because it's more of an domain specific language, but yet it's not that complex. So don't worry about that. So let's just go on with this conditional execution and things like that. But before then, I would love to give you some definition about the data sets and also some definitions about what was it all about when we think of databases in the serverless world. And all right, all right. So now it's always done. So if you morning also I showed you same thing, right? USQL was there, and there was data storage, Azure data lakes, SQL DBs, and there is an SQL DB which is a lot of queries out there. SQL DB from any cloud, or SQL DB from, I think even I can say you something like Logic App has connectivity with Amazon Redshift. There is Logic App connectivity with Impala or else anything. So Cloudera or any other products also has their own. So queries from all your VMs also are taken into consideration, but you have to think about this tiny little piece of block diagram that is always there. That is your Azure data lakes. What does your data lakes do? So in a meanwhile, like let's say you have an application which is building an user base of 100 plus users, and tomorrow your hundreds of users, and tomorrow there is always a reason for your application to fail, because you become so famous that hundreds and hundreds of people give the request for every minute or else every second or else anything. So it's always about upscaling your systems, right? So what does Azure ADLs do is like they have the collection of some sort of a cache system, cache, there is some sort of a monitoring, and your blob storage will have a lot and lot of application inside it. That's like it just forms an accessible component for your data lake. So something like cache and monitoring, you just separately think about this, because this is no way related to the entire architecture, which can be thought about like, okay, we can be designing something more behaviorally serverless. Like all these comes into the picture. So blob is something like, okay, you just put me the data, just going to store it. It's like the lazy piece of puzzle. Like it's like the laziest one in the puzzle, which you can just say. Like all these are there. And also, if you think of something like this, whoa, oh, of course there was StreamYard here, and this was the link that we actually took for ma'am. I think we got pasted here. I think I should always think of some database now. So where is this database? Yep, storage icons. Perfect. So when you think of these kinds of applications, right? Like when you think of something like, okay, you have something which is truly imaginatively possible, like something like, okay, you have 10 million calls of to your database, and now you want to upscale it to, okay, 20 of it, and you really don't know how to do it, and in the meanwhile your company is making lot and lot of profit. So I think we will touch a little bit on queue storage, a table storage, a blob storage. File storage is always there. So we need not have to think about the file storage. Disk is always there as a part of your Azure infrastructure. And if you think of all these kinds of storage systems and all these storage softwares that we are building right now, I don't think so. In another 10 years, it's going to upscale to what it is going to be for the zettabytes of data. I think these make an huge market share today, because from Azure, I think these have their own purpose in the industry. And of course, they will be good enough to just deliver the products and things like that. So that's it, folks, on the theoretical part. Let's just get in for the practicality of building such applications. So right now, let's just get in. Where is my reference guide? This is the one, and there's going to be a portal. Azure has been one of the best infrastructure that you can ever touch upon, like something like there are hundreds of components which are moving right now in the place that you are seeing, but you don't know where to just fill out the form or something. Like you just know, okay, this is what I'm capable of doing, and you just come here and all the products are here somehow. And noting to them. They are pretty good and they're doing pretty amazing when it comes to the consumption model. And let's just get it started. Demo conditions, no loops and switch. Wait, that's fine. No loops and switch. That's perfect. I think it takes some time for validation. Before that, I'll just go and show you how this entire Azure infrastructure runs on the storage and the things like that. So there is something called as a storage account. You just can go here and make the storage. Oh, sorry for that. It should not be written here. Account storage. There is a lot of applications from my side, so I think sometimes my laptop asks for rest, but I don't give it. So let's just get in with some sort of an example here. So there is a storage account here. This is what your storage account is. If you just type storage and things like that, it will come up, and you just go here, start getting the storage account. Now there is an now there is a symbol called as create. Just go and create that. Just type in here all the credentials that you want. I think Logic Apps validated. Now it's time for it to create. It will take some time, but meanwhile, we'll just look at some of the definition here. So let's just say demo, which was conditions demo. So now there is an entire storage system that you're looking at, and you are thinking of like, is there a chance for me to just use all the table, blob, and queues and containers here? So this is where your storage account comes into the picture. And they are so flexible that you can just start building any sort of an application here. So there is standard, that's enough for me. If you are like more into the premium, I'll say what's the biggest problem with that. So there are page blobs and there are file shares, block blobs and things like that. And there is local redundant storage, which will obviously be there even if you don't go for the standard, like the premium one. The standard will obviously have an local redundant storage, and all these applications has their own territory in the Azure environment. Like it's like, of course, I'm just doing this. What next? It's always there. So the redundant storages are here. So if you want to know more about redundant storage, it's here. Redundant storage, Azure. I should say it's Azure. If you go there, there's a data redundancy, and all these kinds of things. You guys can check that out, and this makes a lot of sense when you are thinking of some kind of an application here. And also, there is every time there is a new version of the code, there is a new version of the storage. Sometimes it might show we are still in the preview and the things like that, but the application would have had run it. And also there is always a little bit of a definition here, something like, what about something like, okay, I have this much amount of people next to me, and there is this much amount of desks that I have on the premises, and there's off the premises, that is cloud, and there's this many amount of this, and how can I combine all of them? So your redundancy definitions actually play a huge role here when it comes to data redundancy and the things like that. So I think in the comment section after the video goes up, and we'll obviously have a lot of comments which will be coming up there. So make sure that you see the comments and things like that. So that's perfect. So let's just move on with the demo then. So we gave the definition, it's running the validation. I think it should have it created by now. So let it create by now. So now if you just go here and it's submitting the deployment, let's see if it comes up. So as soon as you click onto that Logic Apps, there will be an, what do you call, this designer stuff opening up. So this is Logic App Designer. As soon as you create a Logic App uh, on an Azure portal, that resource group will obviously have some sort of an edit option here. Sometimes it doesn't come because if you have a standard definition, probably the connectivity towards the VS code is much more needed. So that is not taken into the consideration. But consumption, what I showed in that step, is a must. If you go there, if you type in edit, edit will start putting in. And I think if you do that, you go back to the edits, and there is always an good amount of templates which are always there. So recurrence, everything will be doing in the part 3. Why? Because we need lot of ARM templates, Terraform templates, which will require a lot of definitions there. So we are just going to touch upon that there. So let's see, blob storage is created. Perfect. So conditions demo, blob storage created. Perfect. So I'll even show you how it is all about. So I used all of these. So let's just go on with it. So there's a blob storage here. What I want to do is simple. I just want to see whether there is an blob storage which has been changed or modified. Like if there is an object added, object not done, or things like that. So there is always that definition which we really want. And I don't want that to go here. So I'll just go here, grab my access key and the user's name. So storage account name is here. The storage account name is here. So you can go there and check out what it is. And it works good. Oh, sorry for that. So one time, done. Oh, the custom values, perfect. And now there is a definition for container. Where are you, my dear container? So if you go here, if you type in this entire thing, there is a data storage tab in which you have file share, queue, and containers. I think I'll take two more parts on the Logic Apps itself so that I can explain it in code. All right. So there is always this logs thing which will always be there. This is private. So what I would say is just go out and container, anyone can read, access. So what I say is Vishwas blog demo condition. There is no DNS attached to it. Unlike your AKS, there is no DNS attached to it. Just go nuts with your names. Just go nuts with your any sort of. So all containers in the blob data can be read by any anonymous request. Clients can enumerate blobs within the container by anonymous request, but cannot enumerate container within the storage account. So blobs can be taken into a tool, but never the storage account, which has an access key, which has their own definitions here, can never be taken into the consideration. So successfully created. So what next? You need a container name. So what I did was I have this container name here, and I take it here and I do this. It's perfect. It's been added. And if you think of even doing this also, wait. All right. So let's just delete this and let's just do it once again. So there is a blob storage when there is a change in the blob. Oh, access key. I think I added it. So it's Vishwas access key. And let's just do that. I don't know why it didn't come that time, but maybe didn't ask for it. But let's see. Oh right, I got to know because I had already ran it. So this was a new demo here, and it didn't come up. So there's an Azure. Oh, this is an access key here, and storage account name is this one. name. Where are you? So even if you go for the user account name, it's here and create it, done. You now have and different storage account in which you have an access key design. Since I had already had done an application, so it didn't come up, so now it's supposed to come up. And you have a storage account name and Vishwas conditions demo perfectly added, and there's a container done. So that's why I didn't realize that actually. So now there is a little touch of some sort of a functionality which can also be defined here also at any place, like something like you can have a conditions written, but I don't want to write these conditions. Let's just do this deletion of the blob. Let's just do a serial, then we'll go for the parallel, then we'll go with the condition. So there's a create blob and things like that. Let's just do delete blob only. So it's here, and there is always this one file path. What you can do is you don't have to worry about anything. You can just type in some file path. It's all, it will come up, the file path. Files path is here. So what it does is very simple. It's just taking in one definition of like, okay, you have this many containers, so why didn't you design any system on all these data sets and everything which is available? So it's not about that. Blob is something like there is an always and simple definition of, okay, I have this entity to be analyzed. What next? So it's all the same thing. It's all, it can be GIFs, it can be MP4, MP3s, or CSV files, docx files, PDFs, or anything. Everything still remains same, only with this definition. So you need not have to worry about like, hey, I'm doing this, I'm doing that. What if it doesn't break in or make some changes and things like that? Everything has its own way of doing here. And if you just type in the list of the files path, it's perfect. So it's simple. What I just did is I'll stop my share screen, I'll share my screen once again. Where's my window? Oh, my whiteboard has not yet opened. Then let's just open my whiteboard. My whiteboard is here. So what's happening here is very simple. There is a blob storage here, right? Sorry for my, I don't know, man. Sometimes I've not learned the straight line, so that's why it's like a snake. So let's say, okay, there is a blob storage here, and there is always a container associated with it. So there is always that container which is associated with it, and there is one container which has some file in it. So let it be some GIF, MP4, MP3, or some sort of a CSV file or something. So now when you think of this kind of a file system where there is no no sort of a codec compression and decompression and all these units, like you need not have to worry about the codecs, you need not have to worry about anything. You just have to access the data sets. So codecs and all is never a matter and things like that. So codecs are not supposed to be considered or anything. So what it happens is there's a file here, and this deletion command is just going to delete it off. It's something like it eradicates that entire presence of that file itself. So now, when you think of something like architecting a solution for an entire architecture, which is something like you have 100 million calls and you have 100 million data points to be collected, and you still don't know where to really fetch out what this entire designers are, what we actually require, and things like that. It's not going to make sense, right? So as soon as you save it, it should say save done or the save completed or something. If it's not, then there is there's a missing piece of the puzzle, which is something like probably you didn't had this trigger something, or else something like as good as this. So it's all about the JSONs today. So YAML and the JSON is the language of DevOps. So you can never deny the fact that they are ruling the market. And let's just run the trigger. But before that, let's just go and drop some things in the container. Container is here. So we have a container, we have a demo code, we have to upload something, and as soon as I upload something, like it will not get deleted unless I say run. So there is there's 1.1.png here, so I upload it now. So as soon as I run it, if I refresh it now, it's gone. It should be gone by now. So yes, it should be gone now. So there is no results. So even I uploaded it, but there are no results. But how to check it? Very simple. Just go ahead the same file here and upload it, and it doesn't say that it's not overwriting or if already exists or something. Until and unless I check it, it's just going to do that. So there is nothing called as overwriting or anything. It's been uploaded now. And now if I go back and run the same trigger once again, and after some time it says, okay, there has been say, checks which has been completed, blah blah blah, this has happened here, this has happened there, and everything is running. Let's say what? So now there should be some green ticks. Perfect. If I refresh it, it's not there. So this is a simple serial function that you just drew. And very crucial part, there is always a parallel definition of tasks that you always give. Something like parallel actions is here. So let's just do that. So if you just hover here through, okay, sorry, I need to go as a designer here. So I need to go here as an edit, just go back to that and designer. So if you just can see here, there is an blue colored mark which is here, right? This is the best possible way in which you can really understand what parallel actions can be done. It's like a very tiny little detailing that is required, but it was not told to you. That's it. So you get this tiny little detailing. What you have is if you add an action, it just goes as in serial execution. So I don't want that to happen now. So I just want it to be parallel. So what I did was very simple. I just clicked on that hovered button and I added it as a parallel branch. So the parallel branches have been added now. If you just go here, parallel branch added, and now if you see here, the arrow is showing there is a parallel branch here. And in a meanwhile, when you think of something like you need an table storage. So how can you get a table storage? So we'll do queues also, but queues doesn't mean anything until we go for the ARM template. So let's just remove the queues concept itself. So queues can also be done. Just add this queue, just add it there, it will be done. So there is a container, there is a file share. Of course, it's still the same old blob storage stuff. But what is mainly used is a container, queues, and the tables. Let's say a table, which was applications demo table. And if you just type in here, the table is already created. I don't know who is doing this, but yeah, fine. Perfect. It's already created. It doesn't take too much of time. It's on the same storage account and it does the same thing. So what happens is when you are creating a table storage or inserting a table with a lot of conditions, lot of other stuff, what happens is very simple. There is always one partition key, there's one row key, there is always one entity which will say that, hey, there's a file name and just give me that file name. And the file path has been added. So since that there was a file path which was already added here, the file definition comes in. So I'll show you how this files are defined as paths, which is simple as like you doing cd home slash bin slash ls or something, ls or some mkdi or something, or else all these commands they still work the same way here. So what I can do is there's a table storage here, merge. Insert or merge entity. Merge entity doesn't make any sense, so insert or merge entity is the better one. So yes, since I recently created the table, it's not coming. Wait, it's now created here, right? So I copy the table name and I'll paste it here. Wow. It should never be. It should be always for the partition key. Partition key has its own terms. So let's just add some table values. So partition keys can have some dynamic values. It can have some file display name or anything. But I would say GUID. So what's a GUID? Oh, I didn't show you what happens. The same thing. If I copy the same thing here and I paste it here, this is what you will be seeing all about. So let's just go ahead. It's trigger body zero path. Perfect definition for it. In C sharp, that is fine. New guide method, but GUID in Azure. Our data factory, everything has its own way of saying, okay, this is what has to be done, this is what should not be done. So it's a 32-digit GUID which is associated with Azure subscription. Most of the times it's all about. So it's like Gizmo, WebUI, and all these. So it's not that, but GUID data type is always there. So it has its own hash value and it has its own function. So if you want this, this is there for you in the chat section here. So you guys can go here, get it. Perfect. So designer. I hope I didn't lose my track. Oh yeah, it's fine. Perfect. Right? And there is always that expression, and that expression is always there. That's a data type altogether. If you go type in again, guide, guide is here, and entities are always about that files functions, and it's a JSON value. So what you can do is file name. Now just put a colon and just put this uh, the dynamic value of file names. File name here. So if you do this perfect value has been added, and it's the same old JSON value which can be added here also. So let's see if it gets done. So there is always this parallel execution which is happening. So I hope this has not been taken into it all. So I think I didn't. All right, so let's just. I've saved it now, so let's just refresh it. I don't know why that authentication always has its problem in Logic Apps. Okay, let's just test it out for the containers. If it's working fine, that's cool. It's not. Let's just go back to the same old stuff. So I run the triggers. The triggers has to be run successfully checked. Perfect. Yeah, it's running. Cool. I don't know, man. What happens all of the sudden to this? That's fine. Oh, it's not action. It's parallel actions. So we are doing parallel demo, right? Done there. There, the webinar is done, right? Fine. Perfect. So I think I'm not taking waterfront. Yeah, table storage here, and also if you think of some sort of what is this create table, insert and merge entity, perfect. Oh, what happened? All right, this is going to worse. I think what I'll do is I have one demo which is already ready. This is the problem with Azure, man. Like sometimes the authentication has its own problem to say to me, "Hey, you have not taken this," and things like that. Oh, oh, that's because of the Terraform which is running on GitHub Actions. Okay, it's simple. Azure Active Directory has its own tenant ID, client ID, and everything. So what it showed was something which is Unicode. I think probably that is taking a toll here. I think let's not jump into any conclusions. Let's just go ahead with whatever the demo is. So okay, fine. Wait, sorry for not sharing you the right screen. Share screen now.
Vishwas, I request you to check your voice is bit low.
Okay, okay, fine, fine. Okay, now it's fine, right?
Yes, now it's fine.
Yeah, got it, got it. I think I have shared my entire screen now. Yeah, perfect.
Again, it's less.
Yeah, yeah. I think now you will see the. So it's a new one here. So blob one was what I had. So the same old method of containers which comes here. So the container is here. So the Vishwas container is what I have here. So Vishwas containers and things like that. So there is no file uploaded. So let me just upload something and I'll show you what this entire code and everything does. So it's here 1.1.png and we'll show you some functions and the things like that. So successfully check the trigger and there is no file uploaded. So I think probably now it gets triggered. Okay, successfully triggered. Fine, it got removed. So, what happened in this code was very simple. I did the same when blob storage gets triggered or changed, and there's always this ID which is always there. This was the ID which was being accessed there because in my storage account there is other key vault aspect. Oh my god, it's always complex, and let's not move ahead with it. And afterwards, what I did was the parallel execution really happened. It was the same old insert merge entity, which had the same function. And so now it is 1.1.png, which is added. And it was deleted. And there was an insert merge entity, which was on another other queue storage. Like I can give you a scenario which is very simple. Like let me just say you are a team of hundreds, a team of hundreds 100 plus engineers who work on one problem statement, like something as good as let me say guys have image processing, let's say some stupid task like probably Jira tickets. Let's do Jira tickets. So now, what you can automate, like if the Jira was connected and everything was done, I hope it's connected. If it's there, probably I'll come with a demo on any part of the session. So simple. So there is a task for you to access something on Jira tickets, and you want particular definition of task to be completed in this given point or that given point or something. So what you do is you just make sure that okay, there is a Jira ticket, check what next. So you can't just keep adding hundreds of it. Sometimes you also feel like, okay, I want to delete some things. So deleting it also has a function. So what happened here was simple. I have an immense amount of storage, which is actually triggering some things and things like that. But I'm not as rich as a guy who can really induce hundreds of files in my blob storage and can have it. So probably after processing, I would say like, hey, blob storage, just delete it off. This is what your deletion operation happened. And insert merge operation happens once there is an operation where you have seen that, okay, there is this file being added here, but what should be the absolute purpose of it? So what you do is you distribute among different teams and you distribute among different people and you say, hey, annotate this data, annotate it as one feature, and just throw the same old data set to the other guy who has this entire file system and saying, hey, annotate this data for different features that is missing from the first annotation phase. And all these things play a major role here. Like what I did was, as a condition is very simple. It's very simple here. You just go to the edit option here. Like I'll show you how this edit option is also. Just go to here, add a parallel action or an action. Just go type in something called as control. And as soon as you type control, there will be one orange blue color definition of conditions for each scope, switch, terminate, until. All the things will be there. So I want to just do a condition and just want to say, okay, there is one value here. There is something which is equal to, like, let me just say it's one or something. Or there is an file system here, and SYS team here, and it has some sort of an ends with or else something like it has an PNG file. So I'll be throwing in a PNG file. If I don't throw in a PNG file, it will have another execution. So let me just show you what really happened there also. So your unsaved changes will be gone. I want that only. So it succeeded. Perfect. So I want that succeeded one to show you what really happened there. So as soon as I uploaded and 1.1.png, the condition was written in such a way that if the file system is ending with png, and that was already executed, and that was already happening here. So now let's just do some other stuff like let me just add a zip file or something, a resume. Okay, let's do it somebody else's resume. It's not mine, so I need not have to check on it. So all these things happened, right? The conditions really were favorable here, and there is a true and a false statement which is already been given here, and this didn't get executed. And what you can do is you can go back to the edit option. You can run it once again, and you don't have to save it because it's already saved, but you can just run it. Or else you can, if you, even if you had run the same file there, it would have taken the same thing. I think so. Since I've done this false, right? I don't think any of the things might have happened. But I'll show you what was this. So it's uploaded the resume.pdf. So let's just wait for this. And it's taking time. What happened to this? Let's just do a direct run itself so it doesn't break. So successfully check the run. So I hope it's not deleted. Oh, of course it gets deleted because that condition is just there. And after the condition blocks get executed, everything gets gone away. So it's 6:49 now. So 6:50 it just turned now. So now it was triggered. And if you just refresh it, you will get back to the same old definition of no or something. Yeah, there will be a no definition here. This is what your logic apps are. Like all these mundane jobs can be just optimized with these set of rules here. So if you just go here, oh, just go here, the false statement got applicable because it was not a PNG file that was there. So if you click on the show raw input, if you see that the expression dot thing, it's all simple JSONs. As told, it's always the language of DevOps. Your JSON and the YAML is the language of DevOps, and it got deleted. Why it got deleted? I'll say you why. Let's just go to the edit. Of course, it will take time. I don't know why my internet is lagging or else my system is lagging. Don't know any of it. So perfect that hundreds of engineers and there is a Jira ticket down best. But yeah, it made some sense. So 649, perfect. Let's just show that itself. So what happened was this condition block is one complete entity. Like if this happens, this has to happen, this happens, this has to happen. So it's something like this task one which you have designed here. There's task two which you have, oh sorry, the shape didn't come proper. So there is task two which has been designed here. And there is something called as a task 3. Your conditions will just be here, and whatever has to happen down has to happen only. It's like it's dependent but yet independent over the other form factors of code that we actually saw. If you just type in the same thing on an ARM template, it's still the same thing. It's the same old nonsense which happens, and see how it was just added as file name here and things like that. So I will show you how the tables also have been triggered here. So if you go to the blob one Vishwas is here. So it's tables here. So table one, table two, table three false is always been triggered, and all of these has been added, and all of these have their own access policies and how the table has to go and sit. So row key, position, partition key, everything is here. So you just have to access it. So wait, I'll even show you how this merge also is there. So as I wrote, the entity was still the same old file, and still it's the same old file here, and it's got written onto this table storage. And if I delete any one of them, it's actually, let's just delete let's see, it's merge entities here. So if I delete all of this, like let's just delete all of this. So one, two, three is here, right? So let's get the names of it. False one and one, two, three, and there is an table one. False one, two, three, and table one. Let's not do this because I hope so. There is one more table here. So this table had table one. So let's say I do the same upload and I'll just leave it, but you will see the magic of it. As soon as I delete it, it's gone. So it does not affect the code until now. So let's just go back to the containers here. Try uploading a container file here. Like let's just upload. Okay, I need to go to the container, and inside the container I need to upload it. I can't do that like that. So it's here. Let's upload blob resume.pdf. I'll download it once again. It goes to the no version and see how it doesn't get done. It will never have that succeeded command. It will be like kind of like, okay, we messed around everything. That's what your commands will be. And it's already uploaded. Let's resubmit if you want to resubmit, or else let's do a run history. It will obviously come as some failed. Yes, it's failed because I wanted it to fail. And why is it showing succeeded once? So the run history is failed. Let's just go here and see what is actually happening. So as long as you see that there was always a call which was happening from one or the other table, and now since the false happened, the false was actually taken into consideration, but the other processes didn't happen, and everything got neglected. And it's also easy for debugging sometimes, but very hard when you have some complex data set, like something like last time we discussed in case study on Coca-Cola. Coca-Cola has a complex infrastructure on Logic Apps itself. So it doesn't make sense here. So I think probably if you're doing some chotomoto projects like this, probably it's going to work absolutely fine, and it's going to work. And this is how your debug process is also there. So if you go and run details, it's still the same old code. There are there were none which succeeded. There were four skipped processes that will be in the gray, and aborted will never happen, because sometimes it's like okay, if this condition didn't happen, just stop or something. It didn't happen. And if you see that there was an timing triggers, everything was also there, and there is an millisecond definition here. If you take some other stuff, it will take its own way of interacting and things like that. So, and also if you can go here and check out what is this all about. So you can edit, you can clone it. I'll even show that. So if you go and type this info, what you see on an ARM template in the next session will always be very similar to this diagnostic information. So this diagnostic information that you are seeing right now here is what you will be actually looking at every time when you run some ARM and a Terraform templates. And this is where they make an huge changes in terms of what we are expecting from all the systems that we are running. And I think that's it, folks, from my side. I think thank you so much, Vilsi, for hosting me on this session. I think this was a perfect end for all the things that we could ever build upon. And also, it was always about like Logic App has its own way of building functions, which is a serverless aspect in the Azure. I think we covered all of these. And thank you so much, folks, for your time. And also, if you have any questions, please do comment down below the video, or else, and also reach out to me on LinkedIn. And also, thank you so much for your time and the presence. Any questions, please do reach out to me.